Okay, this is set 7, problem number 19. If you watch my other video on problem number 16, it's very similar. The question was to find the area of the hypocycloid formed by these two graphs, or these equated parametric equations. So hypocycloid looks like this. Again, nothing we really dealt with in class, but that's kind of the hypocycloid shape. You could graph this on your calculator to see what it looks like, but it's symmetrical. And it has 4 equal parts. So what we're going to do is just find this area right here. So I'm going to redraw that, kind of that area. And that little point is when x is 0. So x is 0 when cosine is 0. So cosine is 0 at pi over 2. So we're going to start our integration at pi over 2. And we're going to go to here when y is 0. And y is 0. That's when sine is 0, so that's at 0. So we're going to go from pi over 2 to 0. We're going to draw a little rectangle in there. The height of that rectangle is y, and the width of that rectangle is dx. And now we're just going to substitute. So that's like the basic idea of how you do a parametric area. Now we're just going to go substitute. We're going to go pi over 2 to 0. We're going to go 4 times because we're going to go back to the original shape. There's 4 of them. And we're going to go my y, which is a sine cubed t. And then we're going to go dx. Dx is the derivative of that, which is 3 times cosine squared. I'm dropping the power. It's a power rule first. And then 3 cosine squared, then times the derivative of cosine, which is a negative sine t dt. So now we have, if I bring the negative and the 3 out front, we got negative 12 times the integral of sine to the 4th, because we got a sine cubed and a sine, so we have sine to the 4th t, cosine squared t dt, from pi over 2 to 0. If you look at the answers, that one's not there, but if you take that negative out and switch those two limits, you can go 12 from 0 to pi over 2. Of sine to the 4th t cosine squared dt, and that answer is D.